Before we start section 6.4, I want to review some number theory. The first thing I want to review is the number 1 considered to be prime? By definition, prime means a number is divisible by 1 and itself only, not including the number 1. So based on that definition, the number 1 is not prime. So no, it is not prime. The first prime number that there is going to be the number 2, then 3, then 5, and so forth. Now the second question you want to know, is 0 considered an even, odd, or neither number? Definition of even is this. It says integers that are divisible by 2 is considered even. Odd are integers that are not divisible by 2, such as 15. So then when it comes to the number 0, if you test it out, 0 divided by 2 is 0. The result is an integer. So the number 0 itself is divisible by 2, thus we consider it to be an even number. Learning objective A, we're going to compute number of arrangements using the multiplication counting principle, or strings, that we actually use in section 6.3. So this learning objective is very similar to 6.3, and here's our first example. It says here the Big Ten Athletic Conference consists of 11 teams, and here they are listed. Now you want to predict which team will finish first in a particular sport, which will be second, and which will be third. How many predictions are possible? Well, think about it in terms of the strings. How long is our string going to be? There's 3 decisions to be made, so do 3 spaces. What are your choices? The first choice, when you pick, it's from 11 teams, so it's 11 choices. Well, let's say that Illinois got picked to be first. So if Illinois is picked, that means they can't be picked again in the second position. So in the second position, in this case, they didn't tell you, but you cannot have repeats. So there's only 10 teams to choose from. Let's say we chose Michigan State. So these 2 teams are already in there, which only leaves us with 9 teams left. So this example, even though they didn't clarify it for you, is doing the number counting principle without having replacements. The answer here is going to be 990 options. Now this question over here on the right says, what is the number of strings of 11 different symbols with a length of 3 with replacement? So they've just changed it, and they basically are saying, what if we have to do a string of length 3, so 3 spaces? We're going to choose from 11 different symbols, and we can actually replace them every time. So imagine there's 11 symbols in a bag. Your first choice, you draw in the bag, there's 11. You do replace it, so now when you put it back in the bag, for the second choice, there's still 11, and the third choice, there's 11. So this would be 1,331. So what you want to notice about these 2 examples is how the answer does change when you have replacement versus no replacement. Let's try another one. Here we have a volleyball team, and the team plays 6 players at a time. 3 at the net and 3 behind. How many different ways are there to arrange 3 at the net from the 6 players who are playing? So we're just looking here at the 3 people at the net, and that's it. If you think about it, we have 6 people sitting over here on the side to line up. Our first choice here is 6 options. If a player is standing there, they're no longer in this group, we're down to 5. And then the next one, we take that player out, there's 1 fewer in there, so we only have 4 left to put here. This would be 120 different ways you could line up 3 players from your team of 6 at the front of the net.